Hi everyone, welcome to lecture 2 for module 1, which is cost of poor quality or cost of quality, as most of you know. Before I start, I would like to quote Aristotle and Henry Ford. Aristotle once said that quality is not an act but it's an habit, and Henry Ford said that quality is doing things right when no one else is looking. Means if I need to stay in business, I have to get 100% quality. I cannot compromise on quality. So, if I have to give you one definition of cost of poor quality, a very simple one and a positive one, it is cost of poor quality can be defined as those costs which would disappear if systems, processes and products were perfect. This means I have targeted and achieved 100% quality. Before I move on, I would like to give you two examples of cost of poor quality. They are quite famous examples. The first one is from NASA. NASA launched its space shuttle Challenger in 1986, but it blasted within 73 seconds of takeoff. Why? Because there was a quality failure in the O-ring seal. You know what was most shocking was that NASA managers knew about this potential flaw, but they chose to ignore it because they had a mutually supplier beneficial relationship. And the second rule they broke was that they ignored the warning from the engineers about the dangers of launching the space shuttle in low temperatures. NASA had to bear huge losses. The human loss was 7 astronauts were dead and the financial loss was over $1 billion. If NASA would have chosen to fix the defect, it would have only costed them few $100,000. So, what we learn? The lesson learned from this is that we should always take factual approach to decision making. If we know the facts, we should always use them. The second one is a bit different. It is from Toyota. Toyota in 2009 recalled 9 million cars. Why? Because there was a quality failure. There was a defective floor mat and defective brakes, which led to unintended acceleration. Quality failure is not expected from Toyota because Toyota is a quality leader and it always lived to the motto of continuous improvement. So, why this happened? In 1990s, Toyota decided to become world's #1 car manufacturer. Obviously, quality came second. So, what were the quality rules which were broken? The first rule was there was less employee engagement and the second one was not sharing of best practices. So, these accidents were happening, that is why the quality failure happened. Toyota soon realized this mistake and their president Akio Toyoda apologized for the error and halted production and sale of 8 models, which led to losses. Obviously, there was a human loss, 52 people were dead and 32 injured, and Toyota had to face financial losses of over $5.5 billion. But what we learn from this? We learn that we should always take a proactive approach, and if we know there are defects, we should always try to fix them because quality comes first. Let's go to components of cost of poor quality. So, cost of quality has 4 components. The first one is appraisal cost, then internal failure cost, external failure cost and prevention cost. So, what are appraisal costs? Appraisal costs are those costs which are incurred when the inspection is done when my product is being manufactured. So, this inspection is not done free of cost. It will cost me money, so it comes under appraisal cost. Then comes failure cost. Failure costs are those costs which are incurred due to faulty services, defective products or parts. There are 2 kinds of failure costs. The first one is internal failure cost and the second one is external failure cost. Let's take up internal failure cost first. Internal failure costs are those costs which are incurred when my product has not been delivered. So, whenever, for example, I manufacture this pen, before I can market it, it will go through quality checks. Quality people will check it whether it's fit to be delivered or not. So, for example, they find a batch of pens which is not up to the optimum quality. There might be some ink issues, the ink is just coming out, or the lid is not fixing properly, anything so on and so forth. So there are two kind of internal failure cost, one is scrap and another one is rework. Now what is a scrap? For example, I am manufacturing these pens and the quality people say this pen is not of good quality, nothing can be done on it, no rework can be done, it's a total waste. So money was spent when I manufactured this pen. How? Raw material was used, my machinery was used, manpower was used. So all this has gone waste. So all the money was used, which was used to manufacture this pen, has gone waste. So it's a scrap. Another internal failure cost is rework. For example, the pen is working fine, everything is good, only the lid is not good, it's loose or it's not fitting properly. So what I am supposed to do is I should get a new lid so that I can just market this thing. So if I get a new lid, again it won't be free. Raw material will be used, manpower will be used. So all these expenses are covered under the waste, because I have to waste my first product, only then I could create a new one which could be marketed, and they come under internal failure costs. Then comes external failure cost. I believe they are very dangerous. Why? I am just going to explain you right now. External failure costs are those costs which are incurred by me when my product has already been delivered, it's in the hands of the customer. So it includes warranty issues plus product replacement or repair. Okay. Now suppose I manufacture this pen, I also give a warranty of 6 months, that if there is any manufacturing defect, the customer can replace it or ask for a refund. Now the customer finds this pen is faulty, it's not working properly. So he will use his warranty period and he will either ask me to replace it or repair it. So both will cost me money. So this comes under external failure costs. Now why I say external failure costs are dangerous? Not only it will cost me money, but it will also cost me goodwill. The brand name which I am having, next time the customer will go to the market to buy a pen, he will choose not to buy this pen. Why? Because he had problems when he bought it for the first time. So it will bring down my reputation as a manufacturer. So these are the dangerous costs. Then let's come to prevention costs. I have written them in green because these are good costs. We should be, any manufacturer should be investing in prevention cost. What comes under prevention cost? Customer assessment, process control, quality improvement costs. Okay. Now what are the prevention costs? We all know prevention is better than cure. So if I know I am going to market this, I have to manufacture this pen. What if I just do little market research of what customers need or what other pen companies are offering? So I will do some customer assessment so that I can manufacture the pens which are really in demand. Then I need to control my processes and improve my quality. When I say I am going to improve my quality, this means I am checking if my raw material is good, the ink I am using is of high quality, and my labor or manpower is trained or not. Because if my manpower is trained, I have good processes, I have done customer assessment, this means all these costs will shrink, because the product which I am making has less defects. Obviously, if it has less defects, less inspection would need to be done, so this cost will come down. And if the products are good, there are less defects, this means there will be no or little scrap or little rework, this means I will be saving here. And obviously, if I am manufacturing a very high quality pen or a very high quality product, my external failure cost will be nil, because if the product is good, nobody will ask me to repair or replace it, and obviously I will enjoy a good reputation and more customers will come to me. So what do we learn? I learned that if my appraisal costs are high, then my internal failure costs are high, and my external failure costs are high, this means I am producing lot of defects. If I am giving lot of defects, this means I am incurring lot of these internal failure cost, external failure cost and appraisal costs. I won't be able to stay in market or in business with so many defects. So what should I do? I should be using more money, or I should be investing more in these prevention costs. These are the best ROI, that is return on investment. If I am using my money here, obviously I will be saving here and I will enjoy a good business. Now let's go to cost of poor quality. It's of two kinds. One are the visible costs and the other are the hidden costs. Visible costs are which are obviously very clear, like scrap, rework, warranty issues. We just did them little before, but I am just going to tell you scrap again. If you just remember the lecture 1, that whatever we produce should be in a certain range, like its low spec limit and the upper spec limit. Whatever is produced in this range is acceptable to the customer, you can sell it, and whatever is produced here or here is not desirable. This is just rejected. You cannot sell this stuff. It's rejected. So this is scrap. So the total money you put on producing this scrap or whatever has been rejected is wasted. So this is your visible cost of quality. Then comes rework. Obviously some things need little rework, they need fitting here and there, and then you can sell them, but this rework also is not free of cost. You have to spend some money to get things done. So this is also visible cost of quality. Then obviously comes warranty issues. If there is a customer whom you have given like you have just sold a product and you say it's a 6 months warranty, it's under 6 months warranty for manufacturing faults, he can use his warranty. Either he can ask for replacement, refund, repair. So all this is done. When all this is done, you are spending money on it. So all these are visible costs of quality. And the other one are hidden costs of quality. For example, conversion efficiency of material. So now there's a raw material which you have to make into a final product. So if you are not doing it efficiently, this means you are wasting your material. This is not optimum quality and this wastage is a loss. Then comes inadequate resource utilization. This means your labor or your machinery is not utilizing the resources properly. So this underutilization is also waste. It will incur you losses. Then comes excessive use of material. So for example, think you need electricity to produce something, machinery works on electricity. Sometimes due to negligence or untrained staff, you are using excessively, the material is being used excessively. So all this is waste, it will cause you losses. Then again, control, redesign, reinspection, these are also hidden costs. When you just redesign something or you just reinspect, all this will cost you money. Then comes cost of resolving customer problems. Okay, now the product is in the hand of customer, he is not satisfied. So whatever resources you will utilize to resolve his problem, all these will cost you either in material, in money, in manpower. So it's not free. Then comes lost customer and goodwill. Don't never think that it's only one customer. Obviously, if the customer is not happy with your product, he can tell many people around him that this company is not delivering good quality products. So loss of customer and goodwill are huge losses to any company. You cannot stay in business for long. Then comes high inventory. Obviously, if all these costs are too high, this means you're paying lot for the production and this is not worth it. Then how to resolve these issues, how we can help to be in business, what we should do. So this is cost of quality, finding the incentives, like how continuous improvement will help. I would like to see that you should see this table from bottom to up. So the first cost is prevention cost. The prevention cost is the best cost where you should be spending your money. How? This includes process improvement, product simplification and training cost. Obviously, if you have better processes, your products are more simple and you just spend on training, this means you will be saving here. Like if your staff is trained, your manpower is trained, they will be doing, all the materials will be converted efficiently into high-end products or the final products. They will be using the resources properly, there will be no wastage, very little or less reinspection or redesign. and if the product is good, it doesn't have any defects, the customer would be happy, so there would be no customer resolution problems, and you won't lose any customer. When somebody is paying money, they think that they should get a good quality product, and when they get that, they are happy. This brings goodwill to your company and your brand name, and obviously then the money wasted will be less. So if your prevention costs are up, they increase, this is always better, because then the other cost will shrink. Then there will be appraisal cost will become decline, because there will be little or no inspection, because there are no defects. Then external failure costs, which are warranty issues and product liability, they will also decline, because there will be no dissatisfied customers. Your product are of good quality, they are like the customer is satisfied, this brings in profit and goodwill. And obviously, if you are manufacturing good products, you are using good methods, your labor is trained, so your internal failure cost would be less, there would be very little or no scrap. So all these costs will decline if our prevention costs are up. So this is the best return on investment, and any company or manufacturer who wants to stay in business, he should always focus on quality. Let's move on to traditional outlook to cost of poor quality. Some people, without measuring the actual or the real cost, think that it's waste of time to target 100% quality, it's waste of money to target 100% quality. So what they say is that we should focus on achieving optimum quality level for minimum over cost, as 100% quality will cost them too much. So to prove their point, what they do is they take all the 4 quality costs and they just plot a graph to show how. So I've just plotted the graph for you so that you can know better. Here you can see this is the graph for traditional outlook. Here are my quality levels, and this is the cost per good unit of products. So in blue you can see these are my internal and external failure costs, and in green are prevention and inspection costs. This red curve shows you total quality cost, and here they will mark their minimum total cost, which can be achieved with optimum quality of production. But you can see that this is my 100% quality and this optimum quality, there is a lot of difference between this. Here my products are 100% error free or defect free. So this means if my production is somewhere here, so this means my products and services have error. So what they forget is that if my production is not 100% defect free or error free, ultimately my other costs like internal and external failure cost and prevention and inspection cost will ultimately go up. They will rise, and what I will face? I will face more production costs. So the traditional outlook is a very narrow and a short term approach. You cannot stay in business for long if you are just adopting this traditional outlook. So what's the solution? The solution is quality and competitiveness theory. The Japanese calculated the exact cost of quality and found out that high quality led to benefits and higher sales, and this high quality can be achieved with continuous quality improvement. With continuous quality improvement, I can target 100% quality or defect free services and products. There are many benefits of continuous quality improvement. Basically today we will take 2 of them, that are cost route benefits and market route benefits. First, talking about cost route benefits, if I have just tell you what are the cost route benefits I will achieve with continuous quality improvement, they are increased defect free output. So as we have discussed earlier, if my products are defect free, obviously I will have my internal failure cost, my external failure cost, my prevention and appraisal cost will lower. So basically with time I will have reduced cost of operations. This means quality will become ultimately free. So cost route benefits are good quality led to lower cost and increased profits. Now let's talk about market route benefits. Now what are the market route benefits? if I am producing good quality products, I will have an improved competitive position. I will be in a better standing. If whatever I am producing, a watch or a pen or a car, if I am producing good quality, I am in a good market position, which will lead to high prices and increased market share. Now, if I have to talk about high prices, how? Now, as a customer, when you go to market, you won't mind spending a little bit more for a good quality product, because you know it will give you better services, it will last long. So, if I am producing such a good quality product, obviously I can ask for high prices. And increased market share, if I am producing a good and a high quality product, I am providing high quality services, I will have a loyal customer base. Whenever they need my services, they will come back to me. They won't go to their competitors. They won't go to my competitors. So obviously, I will have an increased market share, which will lead to increased revenue. Obviously, if I am selling more products, my services in our demand, so I will have increased revenue, which will ultimately lead to increased profit. So, market route benefits are, they led to profits and savings to my company. So, this is how continuous quality improvement helps. If as a manufacturer I am working on quality and competitiveness theory and my motto is continuous quality improvement, then it will lead to increased profits, because the result of continuous quality improvement is minimized total quality cost at zero defects. I would be able to explain you better if I use this graph. You can see this graph is different from the traditional outlook. So, let us study it. These are my quality levels, and here I have my 100% quality, and these are costs per good unit of products. So, now if you can see is that if I try to target 100% quality, my internal and external failure cost will ultimately go down to a point where there will be zero. My prevention and appraisal cost will also be less. Why? Because once my production is in line, my staff is trained, so I would lead less inspection, so less money will be going in here. And one major drastic change from the traditional outlook is the total quality cost. It will go down, and the minimum total cost as we reach 100% quality is very less, and it won't go back up again. Why? Because when I am targeting 100% quality, this means that my products and services are error free, and I won't need internal and external failure cost, I won't incur them. My prevention and appraisal cost will also be very less. So, this total quality cost won't go up. So, this is the broad outlook, and if I want to stay in business for long run, then I should adopt the approach of continuous quality improvement. Now, let us take another view of looking at cost of poor quality. It is known as Taguchi's quality loss function. Taguchi is a Japanese quality expert. He said any deviation from the target will cause loss. So, just have a look at this figure. Here you can see its loss in dollars. This is the target. If I produce my goods here, this will give my customer maximum satisfaction. This is the deviation. This is the upper spec limit, and this is the lower spec limit. Anything produced beyond this is waste, or this is total waste. So, Taguchi said, and this is the customer tolerance band, anything produced within here, it is in under the tolerance range. So, Taguchi said deviation will cause loss. Loss is higher the more I will deviate from my target. Whether I move left or right from the target range, losses will increase. What did Taguchi say? Taguchi say, talk to customer about his requirements, just make customer assessment before producing products, and then after knowing the requirements, produce products right on target, because here the customer satisfaction is maximum and the losses are minimum. Okay, take an example. If a shoe manufacturer just wants to make shoes for me, he would ask me about my requirements. I will tell him about the design, the color and the shoe size. My shoe size is 6. and now he produces shoes for me which are not exactly on target, which is shoe size 6. He produces something which is like 6.2, 6.3 or my upper spec limit which is 6.5. So what will happen? Okay, since it's in my range, it's in my tolerance range, I will like, if I really like the shoe color or I really like the design, I will try to adjust. But anything beyond 6.5 or my upper spec limit is waste, I won't be using it. And in same way, if he produces something which is less like 5.8, 5.7 or my lower spec limit which is 5.5, but I really like the color of the shoe, it's going on with my dress, or I know I won't be walking with this shoe, I will try to adjust. But anything beyond that is again waste. So my maximum satisfaction would have been if the shoe producer would have made something which is of size 6, that's the target. But since he deviated, and if it would go out of the spec limits, I won't be accepting that product and it would cause loss. So the basic line is that always know your customer requirements and try to produce the product which is right on target, because that will help your business. That would give the customer maximum satisfaction and it will give you maximum profits. Now let's look at ethics and quality. If a producer is producing something which is substandard work, defective products, poor design, shoddy workmanship, substandard parts and products, if the producer knows that he is producing all these defective products and services and he fails to address them, or he just does not make any effort to correct these things, this means he is breaching his customer's trust. He does not deserve to stay in business because he is not working on the quality of its products. You cannot put quality on stake and stay in business. It is going to hurt your business. So always give quality a lot of importance, because ultimately it will pay and keep you in business for long run. Now let's come to the last topic of lecture 2, which is cost of poor quality and Six Sigma. Understanding Six Sigma without cost of poor quality and cost of quality without Six Sigma is incomplete. Six Sigma benefits penetrate deep into the bottom line. Why? Because Six Sigma targets at customer requirements, cycle time reduction, cost savings and defect prevention. And all this cannot be achieved if our quality levels are low. Quality is low. Six Sigma is not just mindless cost cutting, which results in value and quality reduction. In fact, Six Sigma tries to eliminate those costs which are of little or no use to the customer, and this forms the basis for cost of poor quality. Cost of poor quality determines how much a company is spending, how much revenue a company is spending to fix the defects. For example, if a company is running at 3 Sigma or 4 Sigma, this means they are spending about 40% to 25% of their revenue on fixing the defects. And if a company is running on 6 Sigma, this is only spending 5% of their revenue to fix the defects. You will better understand if you use this graph. You can see that I have plotted my Sigma levels here, and this is the revenue spent on fixing defects. So you can see that at 2 Sigma, if I am operating a company and it's running on 2 Sigma levels, then I would be spending 50% of my revenue to fix the defects, which is quite high, because my prevention, appraisal, internal and external failure cost would be too high. Defect rate is very high, so then the money I am spending on fixing those defects is also very high. At 3 Sigma, I would be spending 45% of my revenue. At 4 Sigma, the amount of revenue I am spending is 25%, and at 5 Sigma, it's just less than 15%, and at 6 Sigma, I am only spending 5% of my revenue to fix the defects. If I convert this percentage into dollar, then this gap is really huge. This means that as the Sigma levels rise, the money I have to spend on defect prevention reduces, This means quality is very important, because Six Sigma is the highest level of quality. The defects produced at this level are really less. So the money I would be using on fixing those defects is also less. Now you might be thinking how sigma levels are associated to cost. You know, sigma is the measure of defects and money is spent to fix those defects. I just plot a graph for you. If you can see, these are the sigma levels and these are the errors, parts per million opportunities. If a company is running at 3 sigma, this means their processes or their products have an errors which amount to 70,000. And if a company is running at 4 sigma, this means the defects are like close to 60,000. And if it's on 5 sigma, then it might be somewhere near 10,000 or less. And at 6 sigma, it's just meager 3.4% of defects. This number is very less. So you would be spending very little amount of money or very small amount of money to fix those defects. So you can see that the graph has gone down gradually. And ultimately, this is just a very less amount of money. Because quality level is quite high at 6 sigma. Now you might have understood how 6 sigma levels are associated with costs. So this would end our lecture 2. Thank you very much.